Okay, so this is the second part of binomial probability. And in this case, we're going to call n the number of trials, p the probability, and x is going to be the number of success in n number of trials. Okay, and so what we talked about was to find the probability of some event k, right? You just take this is NCR right here, of whatever the event is, choose whatever k is. And then this would be the probability of success raised to k. And then this would be the not success part, right, which is 1 minus p to the n minus k. So k is what you're looking for, right? To find the mean, you just simply take n, which is the number of trials, times p, the probability, and that'll give you the expected value. And the standard deviation is just the number of trials times the probability of success times the probability of not success, and then you take the square root of that. So in our example that we've been looking at, if I wanted to find the mean for type O blood type, right, you just multiply 5, because there were 5 kids, times the probability of success is 0.25, and you get 1.25, and so this is the number of kids with type O that's expected. And if I wanted to know the variance or the spread of the data, I would just take the square root of the number of trials times the percent of success times the percent of the probability of failure. So 5 times 0.25 times 0.75, and you end up with 0.968, which means the variance is about 0.0968 from the mean. All right, so should the parents be surprised if more than 3 of their children have type O blood? Well, the first thing we have to do is find the probability of type O blood. And what you would do is you would find, it would be 5 NCR 3, right? So I believe there are 10 trials, 10 outcomes, times 0.25, and you want it raised to the third, times 0.75 raised to the 2. When you type all this in your calculator, you end up with 0.08789. Well, we wanted to know if more than 3 of their children have type O blood. And so more of 3 of your children is the same as taking the opposite, or 1 minus less than 3 of your children. Okay? And so basically when you're looking at the probability of more than 3, you're looking at the probability of 4 plus 5. The probability of 4 of your children having type O blood plus the probability of 5 of your children having type O blood. And so what you would do then is you would type in 10 times 0.25 raised to the 4th, 0.75 raised to the 1, right, plus 10 times 0.25 raised to the 5th, 0.75 raised to the 1, to the 0, excuse me. Okay? You would add all that up, and you would end up with 0.01563. Now I'm going to show you, you can also do this on your calculator. There's 2 ways to look at it. You can look at binomial of PDF, that means the probability distribution, and this would be the complement of the distribution. Okay? And so these are both found in your distribution menu. And so your distribution menu is second bars, which is right here. This button, it's right about in this location right here. So you push second and then that button, and you'll see the distribution menu. And then you have to scroll down and scroll down and scroll down until you get there. Okay, so you guys can go ahead and try this one. First of all, you want to know, is it a binomial variable? And so to test this out, you're going to look for bins, right? So you're going to first test, okay, is there a yes and no solution or success and failure? And so it looks like Patty's going to guess correctly or not, okay? And then is it independent? Yeah, because it doesn't matter if she chose A for number 1, it's not going to impact what she's going to choose for number 2. And then it says, what's the probability, the number of trials? Well, it's a 10-item test, and she's going to choose A through E. So the probability of success is 1 out of 5, because A, B, C, D, E, that's 1, 2, 3, 4, 5. And the probability of failure is going to be 4 out of 5. All right, so if we want to find the probability of X equaling 3, well, we're going to go ahead and type in, you can just go ahead and put it in your calculator. You're going to do BIN, binom, PDF, and you're going to type in, let's see, you're going to type in N, P, and K. So N is the number of trials, which is 10. The probability of success is 1 out of 5. And you want to know if she can get 3. So, okay, when you type that in your calculator, you should get 0.201. So there's a 20% chance that she's going to guess correctly 3 times. Now let's take a look and see, and down here I've shown you how to do that using, without using your calculator. So that would be here. All right, to get a passing score, Patty must guess correctly at least 6 times. So this is the probability of X being greater than or equal to 6. And so in this case, you're going to do the probability of, the inverse, or 1 minus the probability of X being less than or equal to 6. Sorry, less than 5. And so that would include the probability of 5, 4, 3, 2, and 1. So you want to add all those together. And so you do that by doing, because this is not an equal sign here, you have to use the binom CDF, and that's going to be 10 trials, 1 out of 5 success rate. This time it's going to be 5, right? Because you want to know 5 and below. And so you'll do that, and then you'll do 1 minus that, whatever you get as your answer. So when you type that in your calculator, you should end up coming out with 0.0064. So there's a 0.0064 probability, so that's not even 1% chance of guessing correctly 6 times on the test. So remember that next week, Monday, when you have to take the test for this unit, and see if you can do that. So again, here it is. So you're going to use this if you have an equal, and this if you have like inequality symbol. So here we've got the cereal manufacturer, and you got a 20% chance of getting Tiger Woods, 50% of getting a picture of Peyton Manning, and 30% chance of getting Serena Williams. So you're going to buy 5 boxes of cereal, and what is the probability you get exactly 2 pictures of Tiger Woods? So this is your number of trials, right, your N. So we want the probability of exactly 2, and the probability that we're going to use is 20%, because that's the part that contains Tiger Woods, right? So you're just going to type this in your calculator because it's an equal sign. You're going to type in here, so remember to get here you do distribution, and then scroll down. These are the numbers you're going to type in, and hit enter. You should get 0.2048. And of course you can also set it up this way, where you have you want 2 successes, and you're going to end up with 3 failures then, because there's a total of 5 boxes of cereal. So you got about a 20% chance. All right, so this is where we're going to use mean and standard deviation. So you should be thinking of a normal curve. So you should be thinking of z-score whenever you see mean and standard deviation. So we want to find the expected value and standard deviation of x. So to get your values in the table, you're just simply taking this symbol here. Want to fill in the probability table distribution, you would just type in these numbers here for k. 4 for k, 3 for k, 5 for k, and your n is always going to be 5, and your probability of success is 0.25. And you should come up with the expected values for those. All right, to calculate the mean, though, you just take the number of trials times the probability of success. And so in this case, it's 5 kids times 0.25, and you should end up with 1.25, which means that about 1 1/4 kid are going to end up with type O blood. And then your standard deviation, remember that P is the probability of success, and Q is the probability that makes it equal the probability of failure, essentially. So you just take the square root of 5 times 0.25 times the percent of failure, which is 0.75, and you end up with 0.9682. So that's your measure of center, and this is your measure of spread. So let's look at how we can put all this together. So we've got, suppose the Red Cross anticipated the need for 1,850 units of whole blood. And so it's going to estimate that it's going to collect blood from 32,000 donors. There's a probability of 0.06 of you being an O negative donor. So we want to know if Tennessee is going to fall short of meeting its need. So because there's so many values in this, you're going to want to calculate your z-score to figure out if we're going to make it. You can't really use the binomial, the formula in the calculator that we've been using. And so the first thing we're going to do is calculate our mean, which we did here. So it's 32,000 donors times that percent. So we're expecting about 2,000 people to have the blood type we're interested in. Then we're going to calculate our standard deviation, which is 42.4. Okay, and we want to know, we need 18,050 units. So to calculate your z-score, you just take 1850 minus the mean, which is 1920, over the standard deviation, which is 42.4. So this is our z-score. And you should end up with negative 1.65. So then when you go to your table of values, and you look it up because you typed in z-score table.com, you should end up with 0.0495. So there's about a 5% risk that we won't have enough blood for this blood drive. All right, here's another example of tennis players, but I don't think I put this on your, you don't have this one. So let's move on. This is teens and debit cards, so you want to make sure that it is first when it asks, show that this distribution of x is binomial. We'll just go ahead and pause the video and work through this. Good idea to satisfy bins first. So B is has or has not a debit card, independent, yes. There's 506 kids in question. Probability of success is 10% and 90%, and then the answers are all right here. So you want to go ahead and start here, pause the video, and I'll come back. Remember, check for bins. That's what you're doing here. Please note that when you look this up on your Z table, you get 0.7939. That's equivalent to finding the mean, but you have to take one less than because you want that number or more. And so remember, your